right, let's take a look at some inequalities involving one triangle. So here's a triangle LMN, and notice that we're given the side lengths. And our mission is to write the angles in order from smallest to largest. Now this seems a little bit problematic in so many questions in math because it seems like we don't have enough information. And that's the power of mathematical thinking and all the theorems we've been developing in geometry. They actually provide us with powerful tools that let us answer questions that on first inspection seem unanswerable. Well, the fundamental theorem that we're going to use here is that if we look at two sides and one side has a larger length than the other, then the opposite angles, the angles that are sort of opposite those sides, will actually have the similar size. So for example, I see here that this is the smallest side length. That means that this angle must be the smallest angle of all the triangles. This is the next largest length of the sides of the triangle, which means that the angle opposite here, L, must in fact be the next largest. And finally, this is the largest side, and that corresponds to the largest angle. So basically what we're seeing is the following theorem. That if I know that this side, AB, has a length that is greater than the side BC, then that tells me that this angle must be larger than this angle. So then the measure of angle C must exceed the measure of angle A. And using that property here, what I see is that since this is the smallest side, opposite it, in fact, is going to be the smallest angle. And so I see that the the angle M is the smallest angle, followed by the angle opposite the side that has length 22.4, which is angle L, and followed by the largest angle, which is angle N. So there I've written the angles in order from smallest measure up to largest measure. Neat. Great principle. How about this one? Here's a triangle, and the question here is, write the sides in order from shortest to longest. Well, again, we're having a similar issue here in that all we know are actually two of the angles. Wait a minute, we don't even have a third angle? Well, if you know two angles of a triangle, you always know the third, because remember, the sum of the measures of the angles of a triangle equal 180 degrees. If we take 68 and add it to 46, we get 114 degrees. We know the whole thing is 180, so I take 180 degrees and subtract 114, I see 56 degrees, which is this angle measure, and so automatically I get that for free. So that was pretty easy. But what about the sides? Well, a similar result holds. Larger angles are opposite larger sides of a triangle. So if you take a look at this, if we know the measure of angle Z is greater than the measure of angle Y, that means that the length of the side opposite here, XY, must actually be greater than the length of the side opposite Y, which is XZ. And let's see if everyone is happy with that. If everybody is happy with that, 5, 6, 7. Actually, let's just see. Do you notice something interesting here? This really, if you take the sum of these two angles, we get 114. If we take 180 and subtract 114, we get what? We get 66 degrees. Did you see that? If you saw that, good for you. Good for you. Good for you! Excellent. Is everyone happy now? I guess so. All right. So making a subtraction mistake is not good. But you can see how you can check your answer by adding these three angles up and making sure they're 180. All right. So now, the point here is that if the measure of angle Z is greater than the measure of angle Y, then the corresponding sides that are opposite these angles will be correspondingly large. So the side opposite Z will have a larger length than this side here. In particular, what I see is that XY, that length, is going to be greater than XZ. Just as with the angle measures. And so here, since we know all the angle measures, I can tell you which sides, I can write the sides from shortest to longest. I look for the tiniest angle, 46, that's the shortest side, opposite. So DE. That side is going to be the shortest, followed by EF, because that is opposite the next largest angle. And then the last side, which is DF, is the largest because it's opposite the largest angle. So there you have it. We can actually figure out inequalities involving the angles or involving the side lengths just by knowing one. It'll give me the other.